Hello everyone, and we continue building BudgetClick-2026 serverless multi-client, client-side encrypted progressive web application for personal finance tracking and planning. And today we will focus on the last step of the phase 1 development environment, and this last step is set up development as S3 storage. Actually, I set up not only development storage, which is actually not S3 but local, but also I set up the production S3 storage. And as I said, this is the last step of the phase 1, and we even touched this part here, S3 connection, from the next phase. And now let's go through the changes which are made. Well, first of all, I added Lambda's local server and removed Docker configuration. Docker configuration is not required anymore because we run the application as PWA, as a progressive web application, so we can run it either locally as a local development server, or we can run it as PWA also locally, and we do not need any other runtime. So those are the changes in the Docker file. You see that Docker file is removed. Also, the corresponding scripts or commands are removed from the package.json, and we also removed the tasks related, VS Code tasks related to Docker, and we also added the commands or tasks, VS Code tasks for development, which is build server lambdas. I will cover that just in a moment. And we also added run a local storage server. I will also cover that in a moment. Let's start with the local server. So this is the local server. This is a simple web application based on Express. This is a simple web server actually based on Express server, and what it does is exposes two endpoints, get file and post file. So this is the post API endpoint and get API endpoint. So this endpoint, get endpoint, allows the application to get the files from the storage, and post endpoint allows the application save file or update the file on the local storage. Then we needed the similar setup on the server, on the production server, which are Lambda functions. Lambda functions are the serverless functions which are run on AWS Lambda, and they are invoked, so there is no server needed to run those functions, and the functions are invoked when a request is made. I will cover the setup of those functions in AWS console a little bit later. Here they are. So those are two functions, the BudgetClick storage put and BudgetClick storage get. But these here are the files with the code. So those are the TypeScript files, scripts, which are then built into JavaScript. You see that get.js, put.js, those files are built from those TypeScript files. So let's have a closer look at the TypeScript. It has this function get storage URL, and it has the handler. It also has getBase64. So those two are utility functions, and the main function is the handler. The handler is actually the function which is run on Lambda, and this is the main file. It gets the storage path, it gets the key. The key is actually the name of an object stored in on S3, and then we attempt to fetch this file and then just return it as base64. So that's simple. This is basically a proxy, a file server proxy, which we needed because we could not get the files from the web application, and for the same reason we needed the local server, because this is a proxy server, a very tiny server which only gets and updates the files. It doesn't have any other logic, so it's a transparent proxy which will transparently send the files back and forth. We needed those proxies because the web application cannot get and update files on a remote server directly, even if that remote storage is public, and the web application cannot do this because of coarse setting. It's actually possible to set the coarse parameters that way that the web application can actually transmit and receive files from a remote storage, but that would be too complicated and less controlled than with web server proxy for files. So that is the minimal server or the backend functionality we needed, and those lambdas are served on the same domain as PWA. This is also important so that the browser doesn't see this as a security problem, because when the requests are sent from the application located on the same domain as the API it uses, then browser allows this without any special settings, any coarse or anything else. Next, okay, here's we updated the docs. I added the server documentation. It describes Lambda, local development. It describes how to build the server and how to set up Lambdas. Oh, by the way, we don't use list. I'll update it later. So we have only two endpoints, put and get. We will need to set up S3 storage. I'll cover that in a moment. Storage was also updated, storage documentation. So here we have the description of how the storage is organized. BudgetClick supports local and remote storage. The storage type is controlled by user settings. Actually, not only by user settings, but also by the environment variables. The user settings control path to the storage. Here in the application, we have configuration or the user settings, and here we can provide the path to the storage. In this case, this is S3 storage on AWS, and in the local environment, if we run local storage server and run dev client, then we will see that this storage path is set as storage, and that path is located here in the project directory. So this is the git ignored directory, but the directory itself is kept in Git, and for that reason I created this git keep file. The next, we added the storage layer. This storage.ts file changes to config types. I added the storage config, put URL and get URL, and I also updated the config itself. So we have put URL, get URL, which are both located on this domain lighted.com, which is used to serve BudgetClick progressive web application. As I said earlier, this is important so that no security issues are raised by the browser. Now let's inspect this layer. So we have get URL, which is defined by the local environment. So if it's dev, then we serve the files through the local file server, and this is the command which we created, run a local storage server. If it's not development, if it's production environment, then we get this storage path from config.json, which is deployed to the production, and this put URL or get URL is here. Okay, and here we have two main functions, get file and put file. So get file will attempt to fetch the file with this key or the object name or the file name from the storage, from the local storage or from AWS S3 storage, and same will be done here in the put file. It will try to update the file or to post the file with this key and with this body to the required URL, with either local or remote S3. And the last part of this change is the manifest. To test the functionality of storage, to test the storage layer, I added manifest. Manifest file is the main or the core file of this application, and it contains all the information about the data. It's a meta information about the data, or metadata about the data stored in BudgetClick. This is a trivial manifest. It doesn't have any data. It doesn't have any accounts, any categories, any contractors, any chunks, any attachments. There's also no migration, so the migration is number one. The two things that we can change, actually we will change only updated, and we will update it using a test function which is implemented in init.ts, test update. This test update is temporary function located in the new file manifest.ts. Manifest.ts is the service file for handling manifest. It also has this test update, which will increment manifest version and change updated at timestamp. We'll test it a bit later. I updated a little bit the app view. I added the error for not initialized storage. Storage is initialized when manifest stored in state is not null. Yeah, this is state. So we added manifest to the application state. So here we have config settings and new entry manifest. Manifest type was already existing, we did not change it. State itself exports get manifest, save manifest, and initialize manifest methods, and the state TS or the state itself adds manifest data, and in the initialized state it is null, and during the initialization of the application we initialize manifest if settings storage is not null. If settings storage is not set, then manifest is not initialized and it will be null. And in that case, let's say I will remove this, I will save this, refresh. Okay, I also updated this storage pattern to include S3 and local. So this will be for local and this will be for S3. Let me fix this quickly. Clear side data. You see that storage is not initialized because manifest is not retrieved. So if we go to initialize manifest here, initialize manifest, so it will try to get file from the storage with this manifest key. Manifest key is just manifest, and this is the file here, manifest JSON. If this file is not found, then manifest is not initialized. So this file will be found if we specify the correct directory. Save, refresh, and then you see that the application is initialized normally. Okay, so this is about the local part. Settings also updated. You see the changes to the pattern. Now let's see how S3 storage and lambdas are initialized. If you remember, we need lambdas to be located on lighted.com URL. So first of all, let's have a look at the storage. The storage is S3 bucket. Those are the I have already uploaded the manifest file there, and this is URL of this storage: BudgetClick PWA storage S3 US East 1 Amazon AWS.com, and you can see this here. So this is exactly this URL, and as you can see, this application is initialized, so we don't have any errors here, and the manifest is downloaded normally. Let me check here. Okay, so it's downloaded as buffer array, not as files, but it's there. And I can also use, by the way, let's try to test the update of the files on the local. So here's test update network put. Okay, so no errors, and let's check. So it's 1:45 p.m. currently, and let's see if the manifest is updated. Yeah, it's 1:45 p.m. It's 1 p.m. 46. Yeah, and you see that the time has changed again. So update works and get works. which means that our storage layer is working normally. Now let's see if it works in production. So this application in production, okay, I will close this local server, local application. This is productive application in production environment, and it uses this PWA storage bucket here. This bucket is public. In the documentation, storage, by the way, there are test curl commands for getting and putting the files. Here is the policy, the bucket policy, which grants anonymous access to the entire BudgetClick bucket. It allows two operations, get and list. Read write and list. This is the policy, and the bucket itself is completely open. So if we check the properties, if we check permissions, we see that public access is on. So block all public access is turned off, which means that anyone who knows the bucket URL will be able to read and even write files, but it doesn't make it will not expose any data, because the data will be client-side encrypted. So if someone knows the address of this bucket, they will not get the actual data. They will not even be able to understand which files mean what, which files contain what. Next, lambdas. So we have two lambdas, storage put and storage get. So here is the code of those lambdas. This code is built using this command, build server lambdas. So if we run this command, TypeScripts will be transpiled into JavaScripts. We also had to add package.json, which tells the runtime that the modules are common.js. So this is index.js, which is generated from the TS. So this is exactly this file, so just copy and paste. The next thing, API gateways for those two functions. Let's say this one, for example, we created these APIs: get BudgetClick storage get and post BudgetClick storage post. The URLs of those APIs are actually here. So those are the two URLs. So this one, URL 1, and then it has to be translated into actual lighted.com endpoint, and this is done in CloudFront distributions. So this is lighted.com distribution, and here we have BudgetClick storage get. Let's inspect it. This is done in behaviors tab, and if we have a look at this behavior, then we see that there's a path pattern, which is BudgetClick storage get. This is on lighted.com, so altogether it will be https lighted.com/budgetclick-storage/get, this one, and its origin is BudgetClick storage get. The origins are set here in this tab, distribution origins, and those are the origins which we have. If you remember, this was LXCMCXJ1YE, execute API US East 1 Amazon AWS.com. So that was the invoke URL of the Lambda function, and we can find it here. So this is exactly this this invoke URL, LXCMCJ1YE execute API US East 1 Amazon AWS.com, and its name is BudgetClick storage get, and this origin is used in the behavior for BudgetClick storage /get. Yeah, you can see it here. And in the end, we can try if this works. So if I open lighted.com/budgetclick-storage get, then you see that the response is fine. It's actually 400, which is expected, which is good, and this means that there is not enough data provided. Storage path and key are required. Now, what is the storage path and key? We have already covered what the key is. The key is the name of the file in the storage bucket, and the storage path is the user's unique storage path, which is related only to a specific user. So if a user A creates this bucket and uses this bucket, then it will be only the bucket related to the user A, and the user B can use another bucket, and the user C will use another bucket, and so on. So every user will have their own bucket, which is controlled only by them. The application doesn't control the storage. It serves only as a proxy between the user, the client-side application, and the user controlled and user-defined proxies. So the application doesn't deal with data. The application doesn't have the data. The data belongs to the user, and it's also encrypted by the user using the key, encryption key, which is known only to the user. So this is how it works, and we need the storage path. So the application doesn't know the storage path, and the storage path will be served every time a request is made. Okay, now let's test if the API works. Let's open the documentation, storage, and let's scroll down for the test. So this is the test command. So we use curl -i. Let's open the terminal and run this command. Okay, you see that the file is updated. Let's notice first of all the update time. This is August 18th, 5:53. Now let's go and update. Await test update. Let's check the network. So this is the put, which is triggered by the test update. Console. Okay, response received, and now let's test again, and notice that the date has changed. So it was 5:53 and now it's 6:57, and this is exactly the time which we have now, because now it's 6:57. This is how it works. We can also test posting a file. So this file doesn't exist, test.txt. If we have a look at the object stored in this bucket, we see that there's only one object, manifest. Now let's create another one, because the application must be able to both create and update files, because if I create a record for a new month, for a data which wasn't yet stored in this month, that this month chunk will have to be created. So some files will need to be created. So let's run this command. Looks like it worked. Now let's refresh, and you see that there's a new file, test.txt. Let's get the contents of this file, test.txt. Okay, and the contents of this file is hello111, which is exactly like in the update test, hello111. So that will be all for the storage. Let's update the roadmap. Let's mark this as done. Set up development S3 storage. So this is done, and this concludes the phase 1, and in the next phase we'll start the actual MVP implementation. We will start with the application shell, application GUI styling, part of the application shell. We will continue with the initial setup flow. We already touched it, we already have it partially. We'll continue. We will set up IndexedDB, local IndexedDB storage. We will build encryption layer. S3 connection is already done. We don't need to do it again. We will cover synchronization engine. Account management will be needed, because account here is meant as bank account. Same categories, contractors, so those are the reference entities. We will start with records. We will also touch monthly statistics, and basic offline workflow is already covered, but we will revisit it after the application will be built in MVP. So that will be all for this session, and thank you very much for watching, and see you in the next session where we will start MVP implementation.